This is TMUA 2021, Paper 2, Question 15. We're told that a circle has equation x squared plus ax plus y squared plus by plus c is equal to 0 for a, b and c real numbers. And we want to determine necessary and sufficient conditions for the circle to be tangent to the y-axis. Okay, so what does this mean, this necessary and sufficient condition? So this statement is precisely saying that if our condition is necessary and sufficient, if our condition is true, if and only if the circle is tangent to the y-axis. This is two statements. It's saying if our condition is true, then the circle is tangent, and conversely, if our circle is tangent, then our condition is true. Okay, so what does a circle being tangent to the y-axis look like? Well, if you draw an arbitrary circle, this is tangent to the y-axis. And is there any other circle? Are there any other possibilities that a circle could do when it's touching the y-axis at this point, say? Well, it could also be touching from the other side. So there's two different circles which touch the y-axis at this point here. So maybe let's try and work out how this relates to A, B and C. So we need to work out the centre, the radius of this circle. So we can do that by completing the square on this, and that gives us exactly x plus a over 2 all squared minus a squared over 4 plus y plus b over 2 all squared minus b squared over 4 plus c is equal to 0. Then we can move these three terms to the other side, which gives us exactly this. So this describes a circle of, at centre, minus a over 2 minus b over 2, with radius the square root of this. Okay, so now let's put down the idea we said here in two words. So when is it tangent? Well, this is precisely saying that the x-coordinate of our centre is precisely a radius away from the tangent. So it's either has coordinate plus radius or minus the radius of our circle. And how can we rephrase this? Well, this is precisely the same thing as saying the absolute value of our x-coordinate is equal to the radius. So putting this into some maths, we say our circle is tangent to the y-axis if and only if the absolute value of our x-coordinate of the centre, which is minus a over 2, is equal to the square root of a squared plus b squared over 4 minus c. And how may we simplify this to one of the options we're given? Well, because we have an absolute sign here, if we square both sides, this still preserves equivalence. So this is equivalence to a squared over 4 is equal to a squared over 4 plus b squared over 4 minus c. Because going from here to here, that's one direction by squaring both sides. But then this also has reverse implication because this modular sign takes care of the positive and negative square root. So this is an equivalent statement. And now we can cancel this a squared over 4. And we're left with this is equivalent to saying b squared is equal to 4c. And so this statement is equivalent to this statement is equivalent to this, and this statement is equivalent to the condition that the circle is tangent to the y-axis. So our answer is B. There are a couple of alternative methods for doing this. Well, one way is, if you consider this circle, because it's tangent to the y-axis, it means the gradient dy dx of the curve at x equals 0 is infinite. So if you know how to implicitly differentiate, this is another alternative way of getting to the answer, which may be slightly quicker.